in the last videos, we had a very clear discussion about some programs like I think we have seen how to check whether the given number is even number or odd number. Next, and after that, how to find out maximum of two numbers, how to find out maximum of three numbers, how to find out maximum of four numbers. Even we have seen how you can able to, okay, how you can able to swap given two integer values. So there are multiple approaches are there. Then we have seen Fibonacci sequence and even Fibonacci sequence also we covered very clear. Now I'm going to explain few more programs today. One is nothing but sum of n natural numbers. Okay, I want to calculate a sum of n natural numbers. Let us see how you can calculate sum of n natural numbers. Very simple, sir. For this we can go with multiple approaches. Okay, for that we can go with multiple approaches. The first one is nothing but, first let me take n is equal to int of input I am taking. Okay, so I will call function 1 by passing that n value. I will call function 2 by passing that n value. Sir, please concentrate well. I am passing function 3 by calling function 3 by passing n value. Like this, we are sending three values. Now, anyway, we have to define function 1 by taking n as a input, and I am defining function 2 by passing n as the input, and I am passing function 3 by passing n as the input. Like this, I have. So, what is my requirement here is, in these three ways, I have to calculate sum of n natural numbers. First of all, what is those sum of n natural numbers? If you take n value is equal to 5, so first five natural numbers sum, which is nothing but 0 plus 1 plus 2 plus 3 plus 4 plus 5. This is nothing but our expected result. What output we are going to get? 5 plus 4, 9. 9 plus 1, 10. 10 plus 15. Sorry, 10 plus 5, which is nothing but 15, is nothing but the output what we are expecting. So for this, we have to write a program. The first approach, I am going to calculate this by using loop. And the second approach, by using recursion, I am going to explain, but not in depth. Just I will explain at top level how you can use this recursive approach. Sir, next one, I am going to explain this by using, I am going to explain this concept. Do you know by using, so this concept is there, right? Like predefined math formula is there. Okay, predefined math formula is there. By using this also, I want to implement. Sir, what is the math formula? I think you know very well. N into n plus 1 by 2 is nothing but the formula. Can I apply this? So 5 into 5 plus 1, which is nothing but a 6 by 2. 2 3s are 6, and the result what we are getting is 15. Okay, so we will see in all these three cases. Can you please confirm at the top level, is the concept is clear up to this whatever we covered?
Yes.
Sir, please confirm everyone. Can I go for implementation?
Yes, sir.
Yes, sir.
Right. See, the first approach, by using math formula I am taking, simply I am taking n into n plus 1. So try to take double slash it. Sir, why we have to take double slash? Because we know in Python, single slash is going to return floating point result. But I don't want a floating point result. I want a numerical value. That's why I'm taking n value. That's why I'm taking this normal division. Instead of floor division, I'm taking normal double slash. What is the second approach? By using loops, we have to take. Let us consider initially sum is equal to 0, and for each I value in the range of 1 to n plus 1. Okay, for each I value in the range of 1 to n plus 1. Better you can start from 0 also. 0 to n plus 1. Sir, what we are doing? Sum is equal to sum plus I am taking. That's all, sir. At last, can you please return the value of sum? In this case, what will happen? Initial value of sum is 0, and let me execute this process so that you can understand well. Initially, what will happen? Your sum is equal to 0. So your I value is ranging from, let us take the same example, 5. How many values it will generate? So 0 will be there first time, next 1, next 2, next 3, next 4, up to 5 we are going to get. Whenever I is equal to 0, that 0 we are adding to the sum, that result will be stored in the sum. So your result will become 0. Next, take the next I value, add to the sum. 0 plus 1, it will become 1. Take next I value, 1 plus 2, which will become 3. Update here. Take next value, 3 plus 3. Update here. Take next value, 4. 4 plus 6. So update 10. Take 5. So 10 plus 5, 15 is the output. That's all right. It is going to return 15. So what is the third approach is by using recursion. So maybe you are not clear with this recursion at very beginning. If n is equal to 0, I will return 1. I will return 0. Otherwise, I am going to return n plus, I am calling the function 3 by passing n minus 1. Just to see at the top level how it is going to work, I will demonstrate with one example. Let us have a look once. See, consider I am giving the value of n is equal to 5. So initially it is calling function by passing n value as a 5. Sir, is n is equal to 0? No. Then n plus. What is the n value? 5 plus. Again we are calling the function by passing n minus 1. 5 minus 1 will become 4. So is 4 is equal to 0? No. Again we are going to get 4 plus function by passing 4 minus 1, which is nothing but 3. Again we are getting 3 plus function by passing 3 minus 2, which is nothing but 2. Again we are getting 2 plus function by passing 2 minus 1, 1. Again we are getting 1 plus so function by passing 1 minus 1, which is nothing but 0. 0. And you can see here, whenever we are getting 0, what is the output that it is returning, sir? Have you observed 0? Now please listen carefully in the reverse direction. Who called this f of 0? For them it is returning 0. Returned value is 0. This current value is 1. 0 plus 1, 1 it will return. Because this function, total function called by f of 1. And this returned value is 1 and the value is 2. 2 plus 1 will become 3. Returned value is 3, current value is 3. 3 plus 3 will become 6. Returned value is 6, current value is 4. 6 plus 4, 10. Returned value is 5, current value is 10, where we are going to get output as 15. Sir, is it correct or not? Yes, in all the approaches, we got 15 as the result. This is the way how we can calculate sum of n natural numbers by using different approaches. Are you clear with this?
Yes, sir. But which one
Yes.
function should take less time complexity?
Recursion.
Yes, which one is going to take less time complexity among these three? Just guess.
Sir, first function would take definitely order of n, and second one would also take order of n. But I'm not sure about recursion. That's
Yeah,
why I'm asking.
because even we didn't covered about the time and space complexities. Ignore that. But remember, the first one is going to take only one unit, right? Because it is a math formula, right? So we are not placed that inside a loop. So definitely it won't execute multiple times. It will execute only one time, right? So
Got it,
when
sir.
compared with the second function and the third function, the first function is going to take less time. Got it?
Got it, sir.
Any queries up to this, whatever we covered, please confirm.
No.
Right. So let me execute this code. Okay, let me execute this code and check whether we are getting the same answer in all these three cases or not. Okay. So cross check. Py space I am giving test dot py. Sir, it is waiting for the input. Consider I am giving 5. The output is nothing but in all these three cases, we are getting 15 as the result. Suppose if I am giving input as a 0, in all these three cases, we are getting 0 as the output. If I am giving 10, first 10 natural numbers, sum is nothing but what? 55. If we are giving 1, then we will get 1. Like that, it is going to work. I think you people got very clear idea how we can calculate sum of n natural numbers. Friends, is it clear up to this whatever we covered? Please confirm.
Yes.
Any doubts? Please confirm everyone. Is it clear?
Yes.
Right, sir. So the next program, what we are going to discuss is nothing but ninth program. What is the ninth program here is I want to find out factorial of the given number. Okay, I want to take a number and I want to find out a factorial of the given number. Let us see how you can calculate a factorial. So same approach I am using. In the first function, we have some math module is there. Just I am taking factorial of n. There is one math module is there. In that module, so they defined already one function with name factorial. Already they defined one function with name factorial. Just we are going to call that function. Automatically what will happen? It is going to return factorial of that number. So if you want to work with this, just we have to import some module called math. Just we have to import some module called math. In the second function, what we are doing is we are taking a number and the sum is equal to 0. Don't take a sum. Let us take multiplication is equal to 1 because 0 multiplied with any number will give 0 as the result, right? That's why just I am taking multiplication is equal to 1. For I in the range of, don't start generating the number from 0 because again it will take, so 0 into everything will become 0. I am taking 1. And what will happen? Here the formula will become multiplication is equal to multiplication into I. At last, we have to return m. Sir, in this example, what will happen? If you see at the top level, suppose if n is equal to 5. So what is the initial value of m? It is 1. What will be the values of I? I values will be not 0, sir, because we are starting from 1, right? 1, 2, 3, 4, 5. If I is equal to 1, 1 into 1 will become 1. If I is equal to 2, 1 into 2 will become 2. If I is equal to 3, 2 into 3 will become 6. When I is equal to 4, 6 into 4 will become 24. When I is equal to 5, 24 into 5 will become 120. Like this we are going to get. Correct, right? 5 factorial is 121. How to use recursion? If n is equal to 0, sir, what is a 0 factorial? 1, right? Just I am going to return that 1. Otherwise, what will happen? I am taking n into, so function 3 by passing n minus 1. In this case, what will happen? Whenever the value of n became 0, in such cases, it is going to return 1. In the remaining cases, we are taking n into function 3 by passing n minus 1 as the argument. It will be repeated. Okay. Let me cross check and see what will happen here. Sir, just I am trying to run the program. You can see if the input is 5, in all these three cases, we are getting 120. If I am giving 0, what is the 0 factorial? 1. So now I am giving 6. What is a 6 factorial? 720. What is a 1 factorial? 1. So all these cases are working or not? Yes. This is the way how we can calculate factorial of the given number. Friends, please confirm, are you clear with this, whatever I covered up to this?
Yes.
Any doubts? Clear, friends? Right. So in total in this chapter, we have 26 programs are there. 26 programs are there. I covered already 9 programs. With this, I am stopping today's session. The reason for that I already told. So please try to cooperate. Why? Because we have another batch is parallelly running. I am going to map the syllabus for both of you. That's why I am taking few programs every day. But anyway, tomorrow class is there. Around up to 7:45, I am going to take from 7 o'clock onwards. Another 5 or 6 programs I will cover, because the same programs I am taking in the demo session. Okay. So that's why to map the syllabus, I am taking like this, sir. So tomorrow we will meet for the continuation. And from Monday onwards, our batch will be regularized, where you can able to expect 7 to 8:15 like that. We will take the classes. Okay. Please kindly cooperate these 3 days, sir.
Yes, sir.
Sir, I have sent notes.
Madam, already I updated the notes, right? Everyone, I have given access for everyone. Anyone without running notes access?
No.
Everyone received running notes, right?
Yes, yes.
Yeah. So yesterday I updated. You can cross check. Okay, today also I will upload. Right, sir. Thank you. Tomorrow we will meet for the continuation. Okay. Thank you, guys.